Hi, we have a great question to solve. We are asked to determine the derivative of the function x to the power cotangent of x. It comes that, this problem involves the exponentiation where the base function is x, and the exponent function is cotangent of x. In order to compute its derivative, we need to apply the chain rule, and the logarithmic differentiation technique. In this problem, we have to compute the derivative of x to the power cotangent of x. Observe that, this function can be seen as an exponential function because it is obtained by raising x to the power cotangent of x. In this case x is seen as the base and cotangent of x is the exponent. We will have to use the fact that the exponential and the logarithmic functions are inverse functions. Then apply the chain rule to find the derivative. In order to simplify this expression, we will use the properties of the exponential and logarithmic function. We know that, the exponential of log of x is equal x, which is also equal to the logarithm of the exponential of x. Actually, we will also have to use the chain rule. The chain rule implies that, the derivative of the composition of two functions u of v of x is equal to v prime of x times, u prime of v of x. Thus, we express f of x as exponential of logarithm of x to the power cotangent of x. Using the properties of the exponential and the logarithm, see that f of x equals exponential of cotangent of x times, logarithm of x. In fact, we are using the fact that the logarithmic of x to the power y is equal to y times, the logarithm of x. Now, we can take the derivative of both sides and use the chain rule. See that, using the chain rule, the derivative of f is equal to the derivative of the product cotangent of x, times, logarithm of x, times exponential of the product cotangent of x, times the logarithm of x. Actually, in order to find the derivative of the quantity cotangent of x times, logarithm of x, we need to use the product rule. In this case, the derivative is cotangent of x, times, the fraction 1 over x, plus negative cosecant square of x, times logarithm of x. So we have the expression of f prime as follows. This final expression can also be given as follows, f prime of x is equal to the quantity cotangent of x, times, the fraction 1 over x, plus negative cosecant square of x, times logarithm of x, times x to the power cotangent of x.